Good day, my humans. We are working on the exponential function. This is an example of an exponential function. I actually took this one from your worksheet that I handed out in class, and we ran out of time, but this is an exponential function because my x is an exponent. So just in case you're forgetting, remember m of x, this is a function, but this represents your y. So if you didn't like the looks of that, you could just cross them out and write y. So we would have y equals 2 to the x plus 3. Okay, right here in all of these, I've gone ahead and I've just dotted out the 3 that I'm going to do real quick in this video. This is what every standard exponential function looks like. Who cares what the base is? So this would be my function of like y equals 2 to the x, or it could be y equals 3 to the x, or 4 to the x, or 1.5 to the x, as long as this base right here is bigger than 1. Okay, so that's what it's always going to look at. Even if I had y equals pi to the x, I mean pi is still a number. It would just go up a little quicker the larger the base. So I always like to dot these out so that you remember what every exponential function looks like. Now, if I know that, I'm going to eventually learn when I add 3 what that makes my function do. Because my goal is that you guys can do this and only plot 3 points. Okay? This being the first one. And I'm just going to tell you something right now, because I do know that when I add 3, it's going to make my standard function go up 3. So if I was going to do this, I would start with my magic point, 0, 1, and I'd go up 3. 1, 2, 3. So I'd be landing right there. So it's going to look something like this, okay? So it's still shooting up, and then it's flattening out. Now remember, on my standard function, it's getting closer and closer and closer to the x-axis. But because I'm going up 3, it's technically going to get closer and closer to 3. But let me plot just a few points and show you I'm not lying. Okay, so over here I'm going to make just a little t-chart, and we're going to plug this in. And instead of a y, I'm going to write m to the x right here. So show these for a little while until you can figure this out. But here's my favorite point to always plug in. Remember, 2 to the 0 is 1. 1 plus 3 is 4. So there's my first point, 0, 4. And look, I knew that anyway. Okay, let's plug in 1. And then my dog wants in. But if I plug in a 1, I get 2. 2 plus 3 is 5. So I have that point right there, 1, 5. And I do want you, why is it doing that? Let me stand up. Why is it making it? 1, 5 is about right there. Okay, and we'll do one more. If I plug in 2, 2 squared is 4, 4 plus 3 is 7. So give yourself a few, 2, and then we go all the way up to 7. Okay, now here's the deal. When I start to plug in negative numbers, because you can plug anything you want to into an exponential function, remember 2 to the negative 1 is 1/2. Okay, remember, and I'll show you that right here. Remember, 2 to the negative 1 plus 3. Now, let me just say, if you hate that, you can hit that in your calculator just like that, and you'd be fine. But if you hit that in there, you're going to get 1/2, because remember that's 1 over 2, plus 3, which is 2.5. So I've got that right about, about 3.5. As I'm being like so funny, because I'm like, wait a minute. Okay, you might just for kicks plug in something like really big negative, like a negative 5. So you'd have 2 to the negative 5 plus 3. Just use your calculator and get you a decimal for that if you want, but realize that's 1 over 2 to the 5th, and it's not coming through very good, which is 1 over 32. This is a tiny, tiny value in white. My pen's going to die on me right there. This is 1 over 32, tiny, tiny value plus 3. So you can see it's still bigger than 3, okay, but just barely, and that's going to be the case. So when I'm way over here at negative 5, let me see if I can clear that up from my old eyes. We're just barely, barely, barely above 3. So it's something like that. So you can see that it's getting really close to 3. So here's my actual graph. So we're going to do a nice smooth curve. It's going to shoot up really fast. That's why people say things go up exponentially. And it's going to get really, really, really close to this line, x equals 3. It will not touch it, okay, but it's going to get really close to it. Remember, we call that an asymptote. So if you want, we can graph in, this is my actual asymptote right here. So we should technically graph in the asymptote. So I want you to do that. So that's the line. It's getting really, really close to not touching. So my answers right here are my domain. My domain is always on every exponential function. That's your x's. How far does it go to the left and the right? And you can plug in anything you want. So my domain is from negative infinity to infinity. In fact, you could actually fill out your domain for everything. That never changes for an exponential function. Your range is how high and how low does it go. Well, you can show it's going up to infinity, but it's never going to hit anything. It's not going to hit 3 or ever go below 3. So my range looks like 3 to infinity. Remember, this is a parenthesis because it doesn't touch 3. It just gets really close to 3. My asymptote is the horizontal line right here of y equals 3. Okay, so there you go. So you could fix this one on your notes while I'm, kind of do it. Okay, so anytime you've got this where it's added 3 on the back, you just know it's going to go up 3. And you want to know something's cool? This is like a little bonus, but let's say I had this. I'm making up another one, and I'll do it in green. If I had 2 to the x minus 4, I would know I'd start with my standard function, and it's going to go down 4. So all I would do, I start on my magic point, 0, 1, and I would go down 4, 1, 2, 3, 4. So I know it's going to look like this. So guess what? It's going to come up here, and it's going to shoot up. And instead of getting really close to 0, that's what this guy does, it's going to get really close to 0 minus 4. Or it's going to get really close to this negative 4. So this right here is my asymptote. So that should be a dotted line, but it's hard to do while holding my phone. So this is going to come in here, and it's going to approach that line. Never touch it, just get really, really close. So that would be the graph of this guy right here. So simple, simple. And look, I really only plotted 1 point. I'm going to ask you to plot 3, but your graph, so you kind of know how fast he's going up. So I would just kind of do it over here, but just know he's kind of coming slow over here. So again, my asymptote would be the line y equals negative 4. My domain, of course, is all real numbers. My range for this one would be, it's still shooting off to infinity, but my range would be from negative 4 with a parenthesis all the way up to infinity. So they're not too bad if you can learn this little trick right here. Okay, I don't want you to forget this when we did this one in class, okay, but notice the difference. Here, I added it on as an afterthought. And by the way, remember, I could have written this one like this, 3 plus 2 to the x. Remember, you can add in any order you want. But it doesn't really mess with my exponent, okay? So let me just say this. It doesn't mess with the x, therefore it involves my y, and we all know y makes it go up and down. And that did make it go up 3 or down 4. This one's actually messing with my x. It's up here in the exponent, and we know x's go back and forth. So this is going to affect it horizontally. Now you would think that it would go right 3, but if it messes with your x, it messes with your mind. So instead of going right 3, it actually goes left 3. Okay, so here's my standard one that all of them look like. They go through the magic point 0, 1, and it shoots up here. But this guy has been shifted, so he's going to go left 3. So I'm going to start here with my magic point, and I'm going to go 1, 2, 3. So he's going to be right here, and I know he's going to shoot up. So he's going to look just like this, and then he's going to come down here, and he's going to approach my x-axis or whatever. Now, I need to know what's my favorite point, where he's going to hit the y-axis. So, of course, I'm going to do my favorite, and I'll write k of x instead of y. My favorite point, and that would be my y-intercept. But if I plug that in, that 0 plus 3 is 3, and 2 to the third is 8. So that goes all the way up there. So you can see it's going up really fast. So it's going to go whack. So let's see here. I said 3 points. I've got 2. So I would have to do 1 more for my homework. So I would honestly, just find something in here. So let's plug in negative 1. Plug in negative 2. Plug in a fraction for all I care. And then use your calculator if it gets too gross. Negative 1 plus 3 is 2. And 2 to the second is 4. So I've got the point negative 1, 4. So that just kind of gives me some place to aim. Whoop. So it should look something like that. And it's a nice smooth curve. And again, it's going to get closer and closer to the x-axis over here. And so you could technically plug in anything over here. I would suggest when you get to really crazy negatives, just use your lovely calculator. And if you don't know how to use your calculator, ask me, call me, text me, do something. Okay, my domain, of course, is all real numbers. My range is how far to the left and to the, I just lied. My range is how high and